Hi, Algebra 2 students. Our topic for this week is absolute value equations and inequalities. Absolute values appear a lot in engineering and manufacturing, and we have an example of it right here on your screen. We use absolute value statements when we talk about tolerance. If you see that bolt, there is a tolerance allowed for that bolt. It needs to be able to slide into whatever fixture that is. But if it's too long, it won't fit. And if it's too loose, it'll fall right out. And so that's a place that we apply absolute values in the real world and where you would see them. All right. Before we get too far into absolute values, though, we need to work on a little vocabulary. The first two terms we're going to work with this week are called disjunction and conjunction. A disjunction is a compound statement that uses the word or. Okay? A disjunction is true if and only if at least one of its parts are true. So you just need one part to be true and the disjunction is true. Notice when we look at the graph of a disjunction, it's pointing in two different directions. So in this case, x can be less than -3 or greater than 2. And if one of those statements is true, the disjunction is true. Now, a conjunction uses the word and. For a conjunction to be true, okay, all of its parts need to be true. When we look at the graph of a conjunction, you can see that it's connected, okay? So, in order for this conjunction to be true, our x value needs to be greater than or equal to -3 and less than 2. Okay, so it could be greater than -3 and be 5, but it won't be true because it also has to be less than 2. Okay? All right, so let's apply this in writing some statements. So we're going to solve the compound inequality. So since it's a compound statement, it will be a conjunction or disjunction, and then we're going to graph the solution set. So when we solve these, we're going to solve the two parts separately. This part is review. You should know how to solve inequalities. So we're going to solve this one separate from the second one. When we solve inequalities, the steps are the same as solving any equation. The only difference is when you are multiplying or dividing by a negative. So to solve this, I need to divide both sides by 6. It doesn't matter that I'm dividing -24 by 6. Okay, I'm dividing by a positive, so I do not have to flip my symbol. Solve over here. And again, flipping the symbol does not apply to addition or subtraction, just multiplication and division. All right, so I've solved both parts separately, and now what I'm going to do is graph my solution. In order to graph these solutions, we need a number line. My number line needs to include the numbers -4 and -2. I'm going to go a little bit beyond that in both directions. So I'm going to go -5, -4, -3, -2, -1. I'm going to draw circles for each of my values. So I'll draw a circle for -4 and a circle for -2. I color in circles that include the greater than piece or the less than piece, or I'm sorry, equal to, the equal to part. So -2 has that equal to part with its inequality. And now I'm going to draw my line. Oh, I'm sorry, you can't see my graph. Okay, so it has to be less than -4. So less than -4 would be off to the left, and greater than -2 would be off to the right. Notice these two are going in different directions, and that's what we would expect from a disjunction. We see it going both left and right, so that's a check for ourselves that we probably did this right. Let's try one more, okay? This next one, I'm going to solve the conjunction. So again, solve each inequality separately. In order to isolate this c, I need to multiply by the reciprocal. The reciprocal of 1/2 is 2. So c is greater than or equal to -4. And here I have 2 steps. Okay, so the 2 pieces I need to graph are c is greater than or equal to -4 and c is less than 0. I see the word and, I know I'm working with a conjunction. So what I should expect is my graph to be connected. I'm going to draw my number line. I need to include the numbers -4 and 0. Draw my circles on -4. Looks like -4 I need to color in because it has the equal to part. Keep 0 open. Numbers greater than -4 are to the right. Numbers less than 0 are to the left. So now I have my conjunction graph. All right, there's one more example here for you to solve and to graph. I want you to try that one on your own and then check back for the answer. Welcome back. Feel free to pause this and take a moment and check your work. Just make note that we had to divide by a negative over here, and so I had to flip the symbol. That's our rule when we're solving inequalities. Okay, so now that we've looked at conjunction and disjunction, let's talk about absolute value for a minute. Absolute value is a distance. It is the distance from 0 on the number line. Because it is a distance, it is always positive. Okay. I have an example here where I have the absolute value of 3. Okay, so I have the absolute value of 3. What does that equal to? Okay, that equals 3. The distance is 3 from 0. I can see that 1, 2, 3. But I could also go through the other way. I could say the distance is 3 to the left. 1, 2, 3. So in this case, and I'm sorry, I should have put an X there. If I need to figure out, well, what is X? X could be +3 or it could be -3 because both of those are 3 away from 0 on the number line. When we're working with absolute value equations, we have a disjunction. Okay, so that's the connection between absolute value and compound statements. We're going to practice solving some of these absolute value equations, and then we'll put that all together with inequalities. Okay, so let's first start with some equations. In order to solve an absolute value equation, remember we just saw we have a disjunction. That whatever is in the absolute value symbol could be equal to +10 or -10. So we have to solve 2 different equations. Let's set that up. So we're going to solve -3 plus k is equal to 10, or -3 plus k can equal -10. Because remember, whatever is inside this absolute value could be equal to +10 or -10 because it's the distance from 10 on the number line. It could be 10 to the right or 10 to the left. Now we'll solve each equation. Once you have it set up, we'll add 3 to both sides. So k is equal to 13, or add 3 to both sides. K could be equal to -7. Notice the directions do not ask you to graph right now. So this is all you need to do, solve. I also want you to take a moment and check. Notice after you got that answer of +13, because you wrote an opposite on the other side doesn't mean that you can just say, oh, it's positive 13 or negative 13. That's not how this works. You actually have to go through the steps to solve it. Sometimes that might happen when it's just a multiplicative inverse, but not when we have multiple steps or addition and subtraction, okay? Some of you are going to make that mistake. Some of you are going to take the lazy way out, and you're going to get it wrong. So just take the time to solve the equation as you know it. Okay, let's try the next one. What's different about this one is I have this minus 6 over here next to the absolute value symbol. That's not allowed right now because what I want to do is isolate my absolute value so I know whatever it's equal to is a distance from 0. So what I need to do before I rewrite this as a disjunction is add 6 to both sides in order to isolate my absolute value. Negative 2 plus 6 is 4. Now I have an absolute value that is isolated. It is the only thing on the left-hand side. I'm going to rewrite this now as a disjunction. The absolute value of x over 4 is equal to 4, or the absolute value of x over 4 could be equal to negative 4. Solve each of these. Oh, and I'm sorry, when I write my disjunction, I should not be including my absolute value symbols. I'm sorry about that. Let me rewrite it so it's correct. Okay. All right, to isolate x, I see it's being divided by 4. The inverse of that is multiplying both sides by 4. X equals 16, or x equals negative 16. Notice in this case, the answers were opposites because all we had was multiplication in our equation. Okay, when we come back, we're going to put this all together with inequalities. Be excited.